Well, ladies and gentlemen, now we're going to work on our last assignment for the week, which is assignment L. Let me get my pen situated. Oh, let's pick a color. Let's go. Let's stick with black. All right, so assignment L. We're talking about critical angle. Now, critical angle is when we've got material. Here's our normal. Light's coming in at the normal, and it's going to get reflected along the line. If we look at it the other way, here's our line, here's our normal, light comes in, N2 is dense, N1 is greater than N2, not the other way around, and what happens is either get reflected back or gets reflected, or if it's critical, it gets refracted or reflected along the surface. Now this is going to be important because this is how we're going to work with this, because if this critical angle, so sine of 90, or is going to be equal to 0, or equal to 1, I should say. Excuse me, it's going to be equal to 1. So if we look at Snell's law, N1 sine of theta 1 is equal to N2 sine of theta 2. If the sine of 90 of theta 2 is going to be 1, this goes away. So the sine of theta 1 is equal to N2 over N1, and N1 has to be greater than N2, which is air. So usually N2 is usually equal to air or something less dense than N1. So this is what we're going to look at. This is the equation I'm going to use for today. Now, the critical angle for light traveling from a red spinel gemstone into air is 35.8. So theta C is 35.8 degrees. We're looking for the index of refraction for the red spinel. And we're trying to figure out what our, we need to figure out N for air, which is actually 1.0. So now let's go ahead and use the equation. Critical sine of the critical angle is equal to N2 over N1. N2 is going to equal air, because that's what I refracted in. That's where it's going into, and that's going to be 1. So this is going to be the sine of 35.8 equal to 1 over x, which is what we're looking for. Multiply both sides by x, and then divide by the sine of 35.x. X is equal to 1 over the sine of 35.8. So we've got sine of 35.8, and take the reciprocal. X is going to equal 1.709. Let's round to this point, so it'll be 1.71, and that's my answer. So this is going to be in the refractive index of the gemstone, 1.71. And that's how you solve these type of problems. The hardest thing to do is try and figure out what's what. Let me know if you have any questions. Thank you guys, and have a nice day.